equations in two variables. NCERT example exercise 4.3. Question number 3. You have been given a point 3, 4 and the question is, if the point 3, 4 lies on the graph of the equation 3y is equal to ax plus 7, then find the value of a. Now this point is lying on this line. As we know, when a point lies on a line, it will satisfy the equation of the line. This is the equation of the line. This point, if it lies on this line, this means this point is going to satisfy the equation of this line. Point, whenever you represent a point, the first expression represents x, second represents y. So this is x is 3 and y is 4. Now put the values of x and y. Put x is equal to 3 and y is equal to 4 in this relation. So you get here y is 4, 3 into 4 is equal to a into 3 plus 7. Now you see 4 3s are 12, 12 minus 7 is equal to 3a, 12 minus 7 is 5, 5 is equal to 3a, or a is equal to 5 by 3. This is the solution of this question number 3. Now question number 5 of the same exercise. The choices are given, 4 choices are given, and you have to tell that figure 4.6, from the choices given below, choose the equations whose graphs are given in figure 4.6. So the first is x is equal to y. The graphs are given. The graphs are of this form. Question number 5. First part. The graph is given here. Origin, x-axis, y-axis, and this is the graph passing through the origin. The graph is exactly passing through the origin. And you see, the points given are -1, 1. Second point is here 0, 0. And third point, one more point is given here on which this graph passes, through which this graph passes is 1, -1. These are the points, 1, 2, 3, like that. These are the points. Now, 4 options are given. First option is x is equal to y. Second option is x plus y is equal to 0. Third option is y is equal to 2x. And fourth option is 2 plus 3y is equal to 7x. You tell which of these 3 equations, these 4 equations, represent this given line. Now the first point, which is here, is -1, 1. If you put it here in this equation, x is equal to y, you will get x is -1 and y is 1. So -1 is not equal to 1. You see. So this point does not lie on this line. This point does not lie on this line. This means this line, this given line, is not x is equal to 1. because minus 1 is not equal to plus 1. Second point is, you see, x plus y is equal to 0. So here if I put x is equal to minus 1 and y is equal to 1, minus 1 plus 1, that is going to give you 0. So this point is satisfying the line x plus y is equal to 0. But to satisfy a line, we know that there should be at least 2 points, because we know through 2 points one and only one line can be passed. If there is 1 point, infinite number of lines can pass through it. But if there are 2 points, only one line can pass through them. Similarly here, 1 point is not sufficient here, 1 point is not sufficient here, we have to take the second point also. So let's put x is equal to 0 and y is equal to 0, satisfy this here. So here you see, if I put x is equal to 0 and y is equal to 0 in this, x is 0 plus y is 0, x is 0, y is 0, x is 0, y is 0, and that result is equal to 0. So this point 0, 0 also satisfies this line. And similarly 1 minus 3, if I put x is 1 and y is minus 1, so that is, if on adding them you will get again 0, so that is going to, this point is also going to satisfy. So all the 3 points are satisfying this given line. Therefore x plus y is equal to 0 is the solution of this line, or is the equation of this line. So this is the equation of this line, and this is the correct option. Is that clear? Question number 6, exercise 4.3. If the work done by a body on application of a constant force is directly proportional to the distance travelled by the body, express this in form of an equation in 2 variables and draw the graph of the same by taking the constant force as 5 units. Also, read from the graph the work done when the distance travelled by the body is number 1 2 units and number 2 0 units. Here the question says, if the work done by a body on application of a constant force is directly proportional to the product of to its distance travelled by the body and force. So the work done of a body is equal to force into displacement curve. This is work done of a body depends on force and the displacement. S stands for displacement, F for force, W for work. The question says, if the force is equal to constant, that is 5 units, force is 5 units, then you have to form a graph or a relation between this W and S. So here W work done is equal to 5 into S, or simply 5S. It's the equation number 1, let's say, take. Now you will be having here points. At least you have to take 3 points. Here W, you can take here S, and here you can take W. First of all, S is here and W is here. S and W. We were taking X and Y. Similarly, here it is what? W and S. S you can take as 1 unit. So W is equal to 5 into 1, that is 5. S you can take as 2 units. W is equal to 10. S is equal to 3 units. 5 is 15. W is equal to 15. So we are having these values of S and these values of W. S is 1, W is 5, S is 2, W is 10, S is 3, W is 15. Now we come to the graph part. So we will plot the graph for this relation. On x-axis you take S, and on y-axis you take W. S is 1, 2, 3, so here 1, 2, 3, 4, 5, I have taken like that way. And W here 5, 10, 15, so then here it's W is 5, then 10, then 15, then 20, then 25 and so on. Now you see, first is point is S is 1, W is 5, so 1 we have 5, at 1 5, 1 comma 5. Second point is 2, 10, at 2 it is 10, to 2 it is 10. Third point 3, it is 15, 3 it is 15 here. Now you see, join these points. And extend this side also and this side also. Here it will be passing through the origin. Now the question says there are two more parts, subparts here, first subpart and second subpart. The question says now that if from the graph find the work done when the distance travelled by the body is 2 units and 0 units. That is, first is 2 units and second is 0 units. The value of displacement is 2 units. 2 units is here. So you see here, from this point you drop a perpendicular on the graph, and from this point you drop another perpendicular right over here. So wherever it cuts from this point. So this means at 2 it is how much? 10. So at 2, S is equal to 2, W is equal to 10. Second point, when it says 0, S is equal to 0, then the value of W, this means 0 means here, S is 0, 1 and 0, S is 0 here, so 0. So at this point, both are 0. That means W is also 0 and S is also 0. So here, W is equal to 0. So at S, W is equal to 0. At S, when S is 2, W is 10. When S is 0, W is 0. This has to be read from the graph. 2 here, it is 10, and when 0, it is 0. S is 0, W is 0, S is 2, W is 10. Okay.